Okay, so same kind of thing. They're asking us to find the GCF or GCD. Those are the same thing for 886 and 602 using any method we want. I don't know the old Chinese method. You could do the Euclidean, the long divide, rotate, long divide, rotate. I'm going to do prime factorization. I think that's easiest. I found students prefer it over the years. So I'm going to start with the 886. And I'm going to, I don't know what's in an 886, but I know 2 goes in, right? Because it ends even. So divide by 2 on my calculator, and it tells me 2 times 443. The 2's done. Now 443, that's a weird looking number. If you start dividing by things, you divide by 3, 5, 7, 11, nothing seems to go in. Is, the question I'm going to ask now, is 443 prime? Maybe 443 doesn't break down any further. How do you figure out if 443 will break down further or not?
Isn't it if you try dividing or you get the square root of the number and then it gives you whatever number and then you divide into that by 2, 3, 5, 7, and so on until you reach that number.
Excellent. Exactly, right? To find out if it's prime, we got to take the square root, which is 21 point whatever, which means we got to check all the numbers up to 21, huh? We can stop at 21. So I've got to take 443 then, divide by 2, it's a no. Divide by 3, it's a no. Divide by 5, it's a no. Divide by 7, it's a no. You try these on your calculator. I don't even need to try 9 because I already know 3 doesn't go in, and 9's made out of 3 times 3. So of course it's a no. Divide by 11, it's a no. Divide by 13, it's a no. Divide by 15. I really don't even need to check 15 either because 15 is made out of 3 times 5. But you can try it if you want to waste your time on your calculator. Divide by 17, it's a no. Divide by 19, it's a no. And divide by 21, which I really don't even need to check because 21 is 3 times 7. We've already checked 3, but go ahead if you want to. And it's a no. Yeah, so 443 is prime. That's a prime number. So that's weird. So 886 just breaks down to 2 times 443. What a strange number. Okay, now over here, let's do the 602. Let's break it down. 2 again. I'm going to use my calculator. 301. Now 301 is looking pretty weird. Let me try dividing by some numbers. Oh, but if I divide by 7, I found out it's 7 times 43. So 2 is done, 7 is done. Is 43 a prime? Yeah, it actually is. You can check 43 real quick over here. Square root of 43 is 6.5, blah, 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 blah. So stop at 6. Stop at 6 over there. And so then if you go, 43 divided by 2 is a no, divided by 3 is a no, divided by 5 is a no, divided by 6 is no. So 443 is prime. So we're done there. We've broken down the numbers. They're kind of weird numbers. Let's write them down here and line up their primes. So 886 is 2, and then it's got like a 443 way down there, you know, for lining up. And then the 602 is got a 2, and it's got a 7, and a 43. So there we go. Let's line things up now with some lines here. And let's find the GCF or GCD. So remember what you do, you take what they have in common. It's the greatest common factor. So how many 2's they have in common? 1, 2. No 7's in common, no 43's, no 443's. So the GCF is just 2. It's only 2. That's the answer. 2 is all they share in common. So that's the greatest number that'll divide into both of them. It's all they share in common as far as the building blocks go. So there we go. Any questions I can answer on that one?